Now that we have the information about the origins and destination, we can go for the graphic representation. Just a point, my friends, here. You see here it is mentioned it is origin. Okay, it is not correct. It is destination, because origins are here and destination, the distribution centers, are here. So instead of origin here, it must be origin. That I'm gonna fix it later. Okay, now go for the graphical representation of the network we have. The graphical representation, as you can see in front of you, as you can see, we have 3 plans, origin nodes, Cleveland, Bedford, and York, and we have 4 distribution centers as destination nodes. Here, fortunately, we don't have any typo. Okay, another point that you can find in this network that you see in front of you is providing the graph with the information about the demand and supply. Here, as the plant, you see the capacity of Cleveland is 5,000. In fact, the supply capacity of Cleveland is 5,000, and so here you see 5,000 here. In the same way, for Bedford we have 6,000, and for York we have 2,500. You see, when you draw the graph, you providing the decision scientist with more information. The same way you are providing the graph with this information, that in the same time you are providing the decision scientist who wants to use this model for the decision making. Boston, Chicago, and St. Louis, and Lexington. All these demands are the ones that we got from there. So as soon as I refer to St. Louis, I can tell you the demand for St. Louis is 2,000. When I refer to Bedford, I can tell you the supply capacity of Bedford is 6,000. And from Cleveland, you can send to Boston. From Cleveland, you can send to Chicago, to St. Louis, to Lexington. The same from Bedford. So, as you can see, in terms of where to where, we have 12 options from Cleveland. Let me, instead of mentioning the name of the cities, I mention their code. So there are 12 options from 1 to 1, 1 to 2, 1 3 1 4, 2 1, 2 2, 2 3, 2 4, 3 1, 3 2, 3 3, and 3 4. You have, as decision scientists, 12 options in terms of where to where. Another point that is important for us for making decision is the transportation cost per unit. That it is part of the information that the problem must provide you. So here it says per unit you need to spend $3 to send a generator from Cleveland to Boston. You'd have to pay $2 per unit to send a generator from Cleveland to Chicago. And in the same way it continues. For example, if I ask how much does it cost to send a generator from York to Boston, what would be your answer? You check here, York to Boston, so these two should be the answer. And I'm telling you, it's the raw parameters, it's the uncontrollable parameters that we have in this problem. So with these things that you see in front of you, you are now ready for making the decision model to decide about the decision variables that I'm not going to talk about that because I don't want to spoil the problem, the challenge for you. So here we have plans, their names, their capacity. On this side, we have distribution centers, the destinations, their demand, and also their codes. Here, we have the distribution routes that are arcs, that are named arcs, node arc, and also the transportation cost per unit over there. Here also you have some information that helps you to understand the problem better. About a trick that can help you to make better decision variables is when it comes to network models, since there are two dimensions, or since they are two-dimensional, we have origin and destination. Usually it is recommended to use double subscripted decision variable. What does it mean? Double subscripted decision variables in front of or against single subscripted decision variables that we have used before is this. See, for the previous one, for example, we said x1. What was x1? For example, the number of standard golf bags that we created. There is no another dimension to it. There is no other aspect to it. Or, for example, when we put A, that is amount of investment in Atlantic Oil, it is single subscripted. We say x1, we say x2, we say x3. All of them are single subscripted, and that's enough. But when it comes to network models, it would be better to use double subscripted models. For example, when you say x1, 3, it means from origin 1 to destination 3 something. In that way, you don't get confused regarding the many of decision variables you usually have when you are doing a network model. Or for example, when you have x 11 5, it says something between origin 11 and destination 5. But remember, this x11 5 is one decision variable. It is just double subscripted. So here it tells you we use double subscripted decision variables in this class. x11 is the number of units shipped from origin 1, that is Cleveland, to destination 1, that is Boston. x12, the number of units shipped from origin 1, Cleveland, to destination 2, that is Chicago. Totally, the decision variables would be something like xij, number of units shipped from origin I to destination j. How many origins do we have? M origin we have, and we have n destination. So how many decision variables totally we have? We have m, number of origins, times n, number of destination. So keep that point in your mind for your modeling. Let's do activity 1. Still, we are not working on the modeling. We are just trying to learn the model better. Now that you noticed how to define double subscripted variables like x11, x12, and xij, here it provides you a challenge. Formulate transportation costs for units shipped from Cleveland. When you want to do this, you should come and see here. From Cleveland, how many routes are extracted? There are 4 routes from Cleveland to Boston, to Chicago, to St. Louis, and to Lexington. How much does it cost to transport 1 unit from Cleveland to Boston to Chicago? And like that, you have 3, 2, 7, and 6. So with this information that you have, formulate transportation cost for units shipped from Cleveland to any potential places. In fact, when you formulate this, you should come up with a formula that when you give the values to the decision variables, it gives you the total cost for units shipped from Cleveland. Pause it here and check the case and replay this video some parts before you check the answer. To calculate the transportation cost of unit sent from Cleveland, we want to know how many units are sent from Cleveland to Boston. They are gonna be X11. How much does it cost to send each of them? 3. As you can see here, because it says transportation cost per unit from Cleveland to Boston. We go for the next one. How many units are sent from Cleveland to Chicago? X1, 2, because Chicago is the second destination and Cleveland is the first origin. How much does it cost for each unit? 2 plus. With the same logic, we come up with 7x13 plus 6x14. In that way, you cover all the outgoing generators from Cleveland, and also you multiply the cost of transportation from each one. So 3x11 plus 2x12 plus 7x13 plus 6x14. So it is the focus of this activity, and it is the answer: 3x11, 2x12, 7, and 6. Yes. Activity 2 asks you exactly the same question, but this time for Bedford. Of course, you should expect yourself to answer this activity easily. With the same logic that we discussed with Cleveland, the same applies to Bedford, so we come up with the answer as here. 7, 5, 2, 3 are the costs of transportation per unit, and X21 is the number of units sent from origin 2 to destination 1, the number of items from origin 2 to destination 2, origin 2 to destination 3, origin 2 to destination 4. So all the destinations from Bedford. Summation of these things would be the total cost of transportation from Bedford in this model. In the next one, it is very similar exactly as the 2 previous ones. So the answer for this would be 2x31, 5x32, 4x33 plus 5x34. These numbers that you see, 2, 5, 4, 5, you can get them from the graph. But the next activity, the objective function showing the total transportation cost for Foster generators. In fact, activity 1, 2, 3 made you ready for the final objective function that we have for this model, because the objective function is minimizing the total transportation cost. So what are the total transportation costs? It is the summation of the total transportation cost for Cleveland, Bedford, and York, that you already have calculated the total cost associated with Cleveland, Bedford, York. So just sum up them, and the answer would be the objective function, because the answer is the total transportation cost of this model.